This is the assignment for April 20th in Intermediate Algebra, Chapters 11 and 12. We'll introduce the materials that I think important in Chapters 11 and 12. We won't hit all the points, but first in 11.1, 1 through 14, is the square root theorem. This is a very handy device here. The square root theorem works as long as you have an equation that has only one variable, and it is squared in some way. Then you take the square root of both sides to solve your equation. And remember, when you take the square root in an equation, you're going to get two answers, as I will show you. Number one is x squared equals 16. Number two, x squared equals 49. A perfect example of using the square root theorem. You take the square root of both sides. The square root of x squared is x. The square root of 49 is plus or minus 7. Number 3 and 4. Notice you need to get the squared part by itself first. X squared equals 11 on number 4. Then the square root of both sides. You get plus or minus square root of 11. Number 5 and 6. You're going to need to break down your square root. Okay, you get the plus or minus the square root of 20. And as we learned in chapter 10, you break that down with 4 and 5. So it's plus or minus 2 square root of 5. Another thing you do on these types of equations, like on number 8, 2x squared you make equal to the 4. Then you try to get the x squared by itself, so you divide out the 2 into both sides. So x squared equals 2. So square root of both sides, x equals plus or minus square root of 2. Number 9 and 10, the equations are getting a little more complex, as we show here. On number 10, y minus 3 squared equals 4. We take the square root of both sides because the variable's by itself on the left side. Square root of the left side is y minus 3 equals plus or minus 2, the square root of that 4. Then you move the 3 to the other side, so you have 3 plus 2, 5, and 3 minus 2, 1. Then the equation gets a little more complex. Number 12, y plus 4 squared equals 27. Take square root of both sides. Y plus 4 on the left side, and you have plus or minus square root of 27. And you need to break down that 27 as we did in chapter 10. Number 14 has more steps. 4x plus 9 quantity squared equals 6. Square root of both sides, 4x plus 9 equals plus or minus radical 6. Then you move the 9 to the other side, so negative 9 plus or minus square root of 6. And then divide by 4. Negative 9 plus or minus square root of 6 over 4. Then we start working with the quadratic formula, and this is for quadratic equations, meaning they have a squared in them. Number 1, this is the quadratic formula, as I've written there. Number 2, 2x squared plus 1x plus 1 equals 0. The 2 is our a that will go in the quadratic formula. The number next to the x, the 1, is the b that goes in the quadratic formula. The other one, the plus 1, is our c. Number 3, 5's your a, negative 5's your b, negative 7 is your c. Number 4, 7x squared minus 4, 7 is your a. There is no b because there's no x to the first. So b is 0. C is negative 4. Number 5, same way. X squared plus 9 equals 0. 1 is your a. Your b is 0 because there's no x to the first. And 9 is your c. Then number 6, when you're simplifying a fraction like this with 2 parts on top and 1 on the bottom, that number that goes into the bottom must go into every term on top. 5 goes into 5 on top, 5 goes into 10 on top, and 5 goes into 5 on the bottom. That's the only way you can reduce. 1 plus 2 radical 2. Then we start using that formula, the quadratic formula. Number 2, as we see here, p squared plus 11p minus 12. A's 1, B's 11, C's negative 2. We use this formula and we put the numbers in. Just put them in and then work out our work as shown here. As shown. Next page, another example. 5x squared minus 3 equals 14x. The first thing you must do is always make your equation equal to 0. So 5x squared minus 14x minus 3. So your 5's your A, your B is negative 14, your C is negative 3. Then we put them in our formula, as I've shown here, and work it out and simplify all the way. The next page, number 5 and 6, have kind of a special situation. A's 1, B's 10, C is 25. We put them in our quadratic formula. This time we get 0 inside the radical. So we just have negative 10 plus or minus 0 over 2. So it's really just negative 10 over 2, negative 5. We just have one answer. Number 8, y squared plus 5y plus 3 equals 0. You find your A is 1, your B is 5, and your C is 3. You put them in your quadratic formula and work it out. This time we are left with a radical. Next page, number 10, 11n squared minus 9n equals 1. Remember, you got to make it equal to 0. So then your A is 11, your B is negative 9, your C is negative 1. Put it in your formula and you get your answer when you simplify. We had the square root of 125. We must break it down. Then we go on to 12.1. On 1 through 4, we are doing the sum of two functions, the difference of two functions, the product of two functions, and the quotient. For instance, number 2 are two functions. The first one's x plus 4. The second one is 5x minus 2. First step, number 1, we find the sum of the two. We take x plus 4 plus 5x minus 2. Get our answer. The second one, we subtract the second one from the first one. And this gives people a lot of problems. When you are subtracting that second one, you change the signs as I've shown in here. Make sure you change the signs in everything you're subtracting there. We get negative 4x plus 6. The next step, we multiply the two of them together. FOIL. And that's how we get this answer. The last one is the quotient, the one over the other. Number 3 and 4, the same way. We add them together, subtract them, as I've shown there, and we multiply them, and then we divide them. That's the first part. Then the next part is the composite function. We've got three functions we're working with. F of x, which is x squared minus 6x plus 2. G of x is negative 2x. H of x is the square root of x. We are doing composite functions. Follow the steps as I show them, as shown here. This is red. H composite of f of negative 2. First thing you do is you change that to h of f of negative 2. H of f of negative 2. Then in math you work things inside out. So you do f of negative 2 first. F of negative 2 means you put negative 2 back in our function for the x's up here on f of x. Negative 2 squared minus 6 times negative 2 plus 2. Work that all out. It is 18. So then that 18 I found replaces the f of negative 2 right there. Replaces it. So you have h of 18, and that means h of x, the square root of x. So we take h of 18 is the square root of 18. then we break it down. And our answer for this composite function is 3 radical 2. Number 12, f composite of h of 1 comes down to f of h of 1 first. Then, as I said, work inside out, do h of 1 first. That means you take h of 1, you put it in up here, right here, h of 1 equals the square root of 1, which is 1. So h of 1 is 1. Then f of 1, okay, so f of 1, now we come down and put 1 in for the function, again, from up above, x squared minus 6x plus 2. We put 1 in for all the x's there, and we work that out, and we get, should be negative 3. Negative 3 is what our composite function equals. Step by step. Go through them step by step. The final thing for this lesson is from 12.2, inverse functions we're talking about. First, f of 2 equals 11 means the same thing as the ordered pair 2, 11. This is the x-coordinate, this is the y-coordinate. Now we start talking about inverses. If you have the ordered pair 7, 3 in your function, then 3, 7, just turn it around, is in the inverse of the function, which is written f to the negative first x. This f of negative first means inverse of the function. F of negative 1 of x does not mean 1 over f of x like you might think when you have a negative exponent. This f of negative 1 of x means the inverse of f of x. Number 5 is a graph of a function. What can you tell if a function is if a graph is a function? You use a vertical line test, meaning when you draw vertical lines, they will only cross your graph once. That means it's a function if your vertical lines only cross your graph once. Now, to see if the function is what we call one-to-one, which we'll learn more about on the exercises here, you use the horizontal line test. You draw horizontal lines, and if they only cross your function once, each one of them, then it is a one-to-one function. Number 7, if you draw your function and you draw your inverse on the same graph, they are symmetric to the line y equals x. We won't be using that in it at all, but that's a true statement. Number 8, we won't be doing this, but this comes up in college algebra. If you take f composite of the inverse, f of negative 1, which I didn't write out very well, if you have f composite of f of negative 1 of your x, that comes out equaling x. Then if you turn around and take f inverse of your function of x, it also comes out to x. That means they are inverses of each other. And this is something we use in college algebra.